In this lecture, we are going to learn about how to create the custom footprint. So in our project, we are going to create a custom footprint for NRF24. So on the left hand side, you actually see the component placed close to the ruler to measure the distance. So here the important thing is that the circumference of each pin and the distance to the neighboring pins, clearance from the edges of the board, etc. are the things which are very important when designing the custom footprints. You can do this by looking at online documents for the particular part, or if you have the part with you, you can use the ruler to do the measurement. In our case, the distance, the pitch is basically 2.5 mm. You can see the distance between the two pins, 2.54 mm, and this whole diameter is 0.64 mm, and this length is 15 mm, and this is 28 mm. So we need to keep these measurements in mind when designing the footprints for NRF24. So now we're going to create the custom footprint for NRF24. To do that, we will click on this simple footprint editor. So when you click there, then the next step you will do is to click on the new footprint. So here you can enter the footprint name. So I have already entered NRF24. Here you can see. So when you click, when you write here, like for example NRF24, and you press OK, which I'm not going to do because I already have created the footprint name, which is here. When you click OK, then this will appear. Now the next thing which I'm going to do is to separate them. So I'll click M, and then I'll move it a little bit, maybe up, and again clicking M on the reference. I think something is okay, now better. So now the next step in this is to set the grid size. The reason why, because we need 8 holes. We know that in our NRF24 component there are 8 holes, and we need to select the holes that are wide enough so that the pins of the actual component will fit through them, and that the exact distance from the adjoining pins, as we measured, we saw in the slide, should be same. So let's start with the distance between the pins, which was 2.5 millimeter. So to make it easy, we can space the pins at this exact distance, and we will set the grid to be this size, and we can do it from here, 2.54 mm. So now grid size is 2.54 mm, and now the next thing which we are going to do is to put the paths. So you will use this. This is first path, and then second, third, fourth, fifth, sixth, seventh, eighth. So here the next thing we are going to do is to see the path properties, and to do that we will just click E. So for example, here for this one I want to see the properties. I'll click E, and the property will show up, and here you can see this shows the pad number right now is 10. If you want, you can change it. I want to make it 0. And the other things you can see over here, for example, like the shape is circular, and position X and position Y, and orientation, pad to die length. So let's you can change it from circular to oval if you want. So actually the oval shape is in a smaller pad allows for enough solder to make a good connection between pad and the pins, while allowing for a smaller distance between the pads. But in our example, our circular drill hole is fine, so we are going to set the size X to 0.762, which is already written here. And you might be thinking, why do we have this dimension over here, 0.762, whereas the measurements which I showed you in the beginning for the pad was 0.64 mm. We are choosing the slightly higher value to ensure that the pin will fit in the hole. So this is done, and then now you just click OK. So this is your 0, and same thing you will do it for the other ones. So we're not going to change do much change, just here 1, and then okay. I think I'll take this as oval so that I don't have to do it again and again. And here this is your 2, this is your second, so this is 3, and then this is 4, 5, 6, and 7. Now the next thing which we are going to do here is to write the footprint text using this. So you can use this and you can write the text. So for example, my first pin I know is ground, so I can write over here GND, and then you can adjust the width. So let's make it maybe 0.5 mm and 0.5. So the text thickness is too large for the text size, it will be clamped, so it's totally fine. You just click OK, and this ground will appear. So now we have done the same for the other pins. We have written the footprint name, and the one thing you can do here is, if you want, you can rotate these names by clicking by moving the cursor on the text and clicking R. So you can see it is rotated. So in my design, I'll just keep it like that. And the next thing you will do is to draw the silk screen. You know that here we have all the pins arranged, so we will be just drawing a silk screen border so that we have the layout for the component, and the footprints as it will appear on the PCB. It should be done in that way. To do that, first reduce the grid size to 1.27, and that you can do from here, 1.27. Why we did that? So that we have finer control about where the markings for the silk screen will go. Now I am going to use this, and there are different designs which are available. These are pretty interesting in case if you want to have a interesting design, but I'm gonna use this. this. Alright, so this is ready, and I'm going to move this a little bit. Somewhere here. Oops. Okay, now it looks good. And now the next thing we will do is to check whether it matches with our schematic or not. So this is our schematic, and we can see different pins here. At 0 we have ground, and let's take this as well here. And let's match it if we have the similar pin names. So your 0 is ground, C is 1, SCK is 2, MISO is 3, IRK is 4. So yes, I have made a mistake over here, so I need to change the name to IRQ, and then we have MOSI at pins 5, and CSN at pin 6, and VCC at pin 7. Now another thing to do before we save the part and use it to update the footprint properties. So to do that, we will check on the footprint properties button, and here you see footprint properties. So this is going to give us a way to add some properties for the footprint if you want. So you can see here all the pins are mentioned over here, and looks like most of the things are already the way we want. In the description, if you want, you can add like, for example, I'm gonna add footprint for a generic and RF24. So this text will appear in the library as you will search around the paths. So I'll click OK. Now we need to save the footprints, and to do that we will see in the next lecture.